Assalamualaikum and good day, my dear students. I hope you are in a good health and same goes to your family members. For today's class, I'm going to touch on Logical Database Design Part 1b. At the end of this topic, students will be able to derive a logical data model from conceptual ERD, able to derive a set of relations from a local logical data model, able to validate these relations using the technique of normalization, able to validate a logical data model to ensure it supports required user transactions, and able to merge local logical data models based on specific views into a global logical data model of the enterprise. Okay, as I have mentioned earlier, for today's class, we're going to touch on Logical Database Design Part 1b. I assume that you have done revision on Logical Database Design Part 1a. Okay, for Part 1a, you have learned 6 structures that have been found in CERD, okay, or we can call it as conceptual data model to create relations for the logical data model. As usual, for logical data model, of course, you will find entities, relationships, and also attributes. Okay, so for this, I don't have to further explain. Okay, so now for today's class, I'm going to touch on recursive relationship types, complex relationship types, and also multi-value attributes. Recursive relationship type. What is recursive? When you have two entities of similar entity type, we can call it as a recursive relationship type. For recursive relationship, we have two types, one-to-one recursive relationship and many-to-many recursive relationship. Okay, for one-to-one recursive relationship, you need to use the rules for participation for one-to-one relationship. I hope you still remember the rules for one-to-one relationship that you have covered in previous class. For one-to-one recursive relationship, you have 3 types of mandatory participation. Okay, it can be mandatory participation on both sides, mandatory participation only one side, and optional participation on both sides. Okay, so for this slide, it's showing that mandatory participation on both sides. Okay, so for this, it represents the recursive relationship as a single relation with 2 copies of primary key. Okay, and one copy of primary key represents a foreign key and should be renamed to represent the relationship it presents. Okay, so for staff supervised, okay, we're going to have supervision as entity, okay, followed by attribute, staff no, and the supervisee no. So for the primary key, it should be the staff no, and then the foreign key one, staff no, reference staff, and then with the attribute staff no, and prime and foreign key 2 supervisee no, reference to the staff with the attribute staff no. Now for mandatory participation on only one side, you have 2 options. Now, the first option, you can create a single relation with 2 copies of primary key. So for this, you have the staff entity followed by the attribute staff no and supervisee no. So for this, you have the first primary key called as a staff no, and the foreign key supervisee no will reference to the staff no. And for the second option, you can create a new relation to represent the relationship. The new relation would only have 2 attributes, okay, both copy of the primary key. So for this, you have the supervised entities and then the attributes staff no and the supervisee no. Primary key staff no and the foreign key supervisee no reference to the staff entities with the attributes of staff no. For optional participation on both sides, okay, you need to create a new relation as described above here. Okay, supervised entity with the attributes of staff node and supervisee node. So for this, okay, your primary key going to be a staff node, and then the foreign key, you have the supervisee node reference to your staff entity with the staff node attributes. Many-to-many recursive relationship. For this type of a relationship, you need to convert many-to-many recursive relationship into one-to-many binary relationship. Follow the rules for participation one-to-many. So for this, the first entity on one side is designated or chosen to be the parent entity, and the entity on many sides will be the child entity. Second, copy the primary key attributes of parent entity into relation representing child entity, okay, to be act as a foreign key. This is the example showing that the many-to-many recursive relationship. Okay, so for many-to-many recursive relationship that I've explained just now, okay, at the beginning you will have staff with the attribute staff node, okay, supervisor, supervise, supervisee. Okay, so you need to convert this many-to-many recursive relationship into one-to-many binary relationship. Follow the rules of participation one-to-many. So at the final, you will have two entities here, staff and also the supervision. Staff with the attribute of staff node, supervise, supervision, and then another relationship, okay, supervised by the supervision. Okay, so this is the example of many-to-many recursive relationship. Complex relationship types. For this type of second option of complex relationship type. For this second option, first you need to create a relation and include any attributes to be part of this complex relationship. Second, you need to have a foreign key. For this, you need to copy the primary key attributes from the complex relationship to be participate in the new relation. And third, any foreign key that represent a many relationship generally will also form primary key of new relation, possibly in combination with some of the attributes of the relationship. So this is the example for the second option complex relationship type. Okay, you will have new entities here called as a registration with and with the attributes client node, branch node, and also staff node. Client node is the primary key, okay, and the foreign key you have the client node reference client node, and the second foreign key branch node reference to the branch entity with the branch node attribute, and the third foreign key staff node reference to the staff entities and the staff node attributes. Multi-value attributes. First, you need to remove the multi-value attributes from the original entity and put into the new entity that you have created. Second, create a relationship between the original entity to newly formed entity. Let's see the example here. Okay, we have the branch entity here with the attributes of a branch node, address, and tel node. From these entities, okay, branch entities, we can see that the tel node is the multi-value attribute. So you have to remove these multi-value attributes, okay, tel node to the newly formed entity called as a telephone. So tel node is the primary key for telephone. Now branch, you have the branch node as a primary key and address, okay, as the attributes. Okay, branch with the branch node and address attribute, and telephone entity with branch node and also tel node attribute. nodes. Okay, as tell node is the primary key. Summary derive a relation. So this slide shows the summary of how to map entities and relationship to a relation. So we have types of entities and relationship here with its mapping. Like example, strong entity is to create a relation that includes all the simple attributes. For weak entity, you can create a relation that includes all the simple attributes. Primary key still has to be identified after the relationship with each owner entity has been mapped. So you need to go through each of these entity and relationship and its mapping. Okay. This figure shows the conceptual data model for staff client user views, okay, with all the attributes. Okay, staff with the attributes of staff name, and then position, sex, and DOB. And then for client, you have a client name, and email. Okay. Now, this slide shows relations for the branch user views of Dream Home. So you have the branch entity with the attributes of branch node, street, city, postcode, and manager staff node. Okay, with the primary key, alternate key, foreign key, and then you have a telephone entity with the attributes, primary key, and the foreign key. This is the example, okay, that you should have, okay, for your relation. Okay, entities, primary key, alternate key, and also the foreign key. Now you can try this practice. Okay, you have practice 1, practice 2, practice 3, practice 4. So the rest of the steps in logical database design, you have step 2.2 where you can validate the relations using the normalization, okay, which will be discussed more detail in chapter normalization. And then step 2.3, validate relations against user transactions. Step 2.4, check the integrity constraints. And step 2.5, review the local logical data model with the user. Step 2.6, merge local logical data modules into the global model. This optional step. And then the step 2.7, check for the future growth.